Somewhere right now, a 30-year-old Japanese car is outrunning every modern vehicle on the road. Not in speed, but in pure survival. No software updates, no dealer visits, no excuses. The engineers who built these machines were operating under one rule that no car company on Earth follows anymore. And that rule is the reason these cars simply refuse to die. Car 10, Toyota Corolla E100. The most forgettable car ever built, and that was the entire point. Everyone assumes the Toyota Corolla E100 was cheap because Toyota cut corners. They cut nothing. The development chief had one obsession: build a mini Lexus. So he took the NVH reduction technology developed exclusively for Toyota's flagship luxury sedan and buried it inside a compact that nobody took seriously. The 4A FE and 7A FE engines, cast iron block, fuel-injected, 1.6 to 1.8 liters, were deliberately calibrated to run at 70% of rated capacity. Not because they couldn't go harder, because an engine block that never works hard simply never wears out. The double wishbone front suspension gave it handling that embarrassed cars costing twice as much. The multi-link rear suspension, borrowed directly from the Lexus parts bin, absorbed road impacts that rattled competitors to pieces. Germany's 1995 ADAC reliability survey confirmed what Toyota already knew: 5.3 breakdowns per 1,000 vehicles against the Volkswagen Golf's 12. Today, your modern sedan needs a software patch every 90 days. The E100 needed an oil change. In the Philippines, they still call it the million peso car, because it earns exactly that before it ever needs serious work. 30 years after production, these cars are not in museums. They are not in collections. They are working daily. Lexus engineering at a budget price. But Honda did something even more extreme. They made theirs boring by deliberate design. Car 9, Honda Civic. Honda deliberately made this car forgettable and accidentally made it immortal. Honda held one meeting. Engineers asked one question that no modern manufacturer would dare ask today: what happens if we remove everything that is not absolutely necessary? Every unnecessary system, gone. Every failure point, eliminated. The Honda Civic EG 4th generation and EK 5th generation, produced 1988 to 2000, ran D-Series and B-Series engines, 1.5 to 1.6 liters, SOHC and DOHC configurations, with fewer moving parts than almost anything on the road. The double wishbone suspension front and rear gave handling precision that sports car drivers respected. The cable-operated throttle had no electronics between your foot and the engine. Direct, mechanical, unfailingly honest. Verified average annual repair cost: $368. Your modern crossover averages over $1,200. Owners cleared 300,000 miles on oil changes alone. In Indonesia, these Civics run as taxis 20 hours a day for decades without opening the engine. Honda made this car boring on purpose. Every manufacturer today makes things complex on purpose because complexity creates return visits. Honda went the opposite direction. That is why this car is still running, while theirs are already in junkyards. Honda chose simplicity. Subaru chose something far more aggressive: engineering for conditions where simplicity alone cannot keep you alive. Car 8, Subaru Legacy Outback. Every other car on this list stops in winter. This one was just getting started. Subaru built the Legacy Outback 1st generation for environments where everything else stops working. The EJ22 2.2-liter flat-4 boxer engine, horizontally opposed cylinders, cast iron block, permanent symmetrical AWD, cold-tested to -30 degrees Fahrenheit. At temperatures that crack engine blocks on other vehicles, the EJ22 starts on the first turn, every time. The boxer layout sits so low in the chassis that the center of gravity drops below what any inline or V engine can physically achieve, creating stability that drivers feel immediately on ice and snow. No computer managing the AWD, no algorithm, always engaged. always working mechanically. The head gasket issue that plagued later EJ25 engines never appeared on the EJ22. The bore-to-stroke ratio was so conservatively tuned that thermal stress simply never built up to dangerous levels. In Vermont and Maine, states that destroy most cars within 5 years through salt and freeze cycles, first-generation legacy Outbacks survived decades with original body panels intact because Subaru galvanized every external panel and engineered the undercoating for a lifetime in salt-covered environments. This was not standard practice. This was deliberate over-engineering for the worst-case scenario, built for the coldest conditions on Earth. The next car was built out of something far more human, pure corporate anger. Car 7. Nissan Altima. Nissan's previous model failed publicly, so they built this one as revenge. Here is the story no journalist tells you. When the Nissan Stanza failed, losing to the Toyota Camry and Honda Accord across every reliability metric, Nissan's engineers got angry. The Nissan Altima first generation, 1993 to 1997, was over-engineered out of corporate spite. The KA24DE 2.4-liter inline-4, dual overhead camshafts, cast iron block, forged steel crankshaft, where every competitor used cheaper cast units, was built with tolerances that had no business inside a family sedan. The suspension geometry came directly from Nissan's performance division. The multi-link rear setup delivered handling feedback that sports car drivers noticed and commuter car buyers got for free. Mechanics opening these engines today still make the same comment. Everything inside is unnecessarily strong for a basic commuter car. That unnecessary strength is exactly why these engines clear 300,000 miles on original internals. Nissan built this car angry. Anger, it turns out, produces extraordinary engineering. Spite built the Altima. The next car was built by engineers with something even more powerful: an impossible mission. Toyota Land Cruiser. In production for over 25 years, zero computers, zero compromise. The Toyota Land Cruiser 70 series launched in 1984. Still in production today, the 1.8 4.2-liter inline-6 diesel, cast iron block, mechanical fuel injection, zero ECU. Designed around one rule before a single component was drawn. If it requires a laptop to diagnose, it fails. 129 horsepower, 300 Newton-meters of torque at just 1,800 RPM. Maximum torque at minimum stress, meaning the engine never strains during normal operation, ever. The solid front and rear axles gave approach and departure angles that independent suspension systems physically cannot match. The coil-sprung suspension on later models combined off-road articulation with on-road comfort that nothing in its class replicated. The UN, Red Cross, and Médecins Sans Frontières all spec this drivetrain for remote deployments because any field mechanic fixes it with basic hand tools in the middle of nowhere. Your modern SUV needs a dealer diagnostic computer before anyone can diagnose a warning light. The 1.8 needs a wrench. In Australia's Outback, one documented Land Cruiser outlived 3 generations of the same farming family. That is not marketing. That is a maintenance record. Car 5. Honda Accord. 185 oil changes, 72 sets of tires, original engine, never opened. Joe LaCicero bought a Honda Accord CB7. He drove it to 1 million miles. Original F22 2.2-liter engine. Original automatic transmission. Neither ever opened. 185 oil changes, 9 timing belts, 13 sets of brake pads, 72 sets of tires. The engine itself? Nothing internal, ever. The CB7 used a forged steel crankshaft and cast iron block, components found in commercial trucks, not family sedans. The double wishbone suspension front and rear gave it handling so precise that drivers who switched from sports cars reported no compromise. It was the last Accord to avoid the head gasket failures that destroyed the reputation of every model that followed. A separate verified 1991 CB7 confirmed at 1.16 million miles. Modern sedans are engineered for 150,000 miles. Honda built this one and forgot to put a ceiling on it. 5 cars in, and every single one should not exist by modern engineering standards. Yet here they are. If that tells you something real about what this industry lost when profit replaced soul, hit subscribe. Next week, we go even deeper into the engines that refused to die. Toyota 4Runner. Toyota built 6 generations of this truck. Only one became impossible to kill. 6 generations of the Toyota 4Runner exist. 5 are reliable. 1 is legendary. The Toyota 4Runner 3rd generation, 1996 to 2002. Unanimously the most reliable generation ever produced. The 3.4-liter 5VZ FE V6, aluminum head, cast iron block, crosses 300,000 miles with 0 major failures. As a standard, not an exception. The timing belt replacement at 90,000 miles is the single most important scheduled maintenance item. Do it, and this engine simply does not stop. The 3RZ FE 2.7-liter base engine was so deliberately understressed that mechanics find them clean past 250,000 miles with no cylinder wall wear. A mechanical 4-wheel drive lever, not a button, not software. Nothing to corrupt, nothing to fail. The solid rear axle gave off-road articulation that independent rear suspension cannot replicate and was engineered beyond the truck's own official load ratings. The skid plates were standard equipment because Toyota assumed owners would use the truck for what it was designed for. Modern 4Runners need dealer computer resets for basic functions. This generation needed a lever and a key, nothing else. One legend. Now the car that made the entire global tuning world completely lose its mind. Nissan Skyline GTR. Cast iron block, same material as a semi-truck engine, inside a sports car. In the 1990s, every performance manufacturer was chasing lightweight materials. Nissan went the exact opposite direction. The Nissan Skyline GTR R33, 1995 to 1998. Built around the RB26 DETT 2.6-liter twin-turbocharged inline-6, a cast-iron block sharing material specifications with heavy commercial truck engines. Forged crankshaft, forged connecting rods, cylinder walls thick enough that the stock unmodified block handles 800 horsepower, verified by professional tuning operations on multiple continents. The factory twin Garrett T25 turbochargers fed a plenum chamber intake that Nissan engineers designed specifically to allow future power increases without intake manifold replacement. They built in the upgrade path from the factory floor. The Atessa ETS all-wheel drive system, multi-plate clutch transfer case, torque distribution in milliseconds, gave traction that rear-wheel drive competitors could not touch in any condition. The Brembo brake system specified from the factory. The Bilstein suspension tuned for both track and road. Nissan built a car that could be driven to a circuit, set a lap record, and driven home. At 800 horsepower on factory internals, 30 years later, the tuning world still calls it one word: unkillable. Cast iron. Forged everything. Built like a truck. Now the truck that survived a building collapsing directly on top of it. Car 2. Toyota Hilux. 3 days. Every method of destruction known. The truck survived every single one. Jeremy Clarkson drove a Toyota Hilux 5th generation into a tree. The engine kept running. He submerged it in the ocean overnight at high tide. Pulled it out. The 22RE 2.4-liter inline-4, high-nickel alloy steel block, chain-driven camshaft, 0 timing belt to ever snap, started. He hit it with a wrecking ball, set it on fire, detonated a 23-story building directly on top of it. The engine started every single time. Toyota's response? They launched a new trim level and named it the Invincible. The 22RE uses a cast iron block with nickel content that gives dimensional stability under thermal and mechanical stress that ordinary steel cannot match. Documented examples cleared 500,000 miles under brutal daily commercial use. A 1980 Hilux crossed 1 million miles on YouTube. Driven hard, suspension components replaced as needed. Original engine never opened. The leaf spring rear suspension gave load carrying capacity that coil spring setups cannot match under real commercial abuse. The body-on-frame construction allowed individual panels to be replaced without chassis repair after impact damage, which is exactly why these trucks survive conditions that would write off a modern unibody SUV. Across conflict zones in Africa and the Middle East, military units, aid organizations, farmers all made the same choice. Not fastest, not cheapest. Still moving when everything else had already stopped. Everything tried to kill it. Nothing worked. The car coming next cost $1 billion, and it reveals the one rule behind every vehicle on this list. Lexus LS400. $1 billion, 1,400 engineers, one rule, and here it finally is. In 1983, Toyota made a decision the entire industry called insane. Build something better than Mercedes-Benz, more refined than BMW, sell it for less. The Lexus LS400 launched in 1989 as that answer. 1,400 engineers, 2,300 technicians, $1 billion. 6 years, one car. The 1UZ-FE 4-liter V8. Aluminum block, dual overhead camshafts, 32 valves, individual throttle bodies, forged steel crankshaft, balanced to jet turbine tolerances. The engine mounts were hydraulically isolated, not rubber, hydraulic, so no vibration frequency from the engine could reach the cabin at any RPM. Engineers stacked 15 champagne glasses on the running engine at 145 miles per hour on a dyno. Not one glass moved. GM engineers disassembled early LS400s and formally concluded they could not replicate the build quality in mass production for 5 to 7 more years. The automatic transmission shifted so smoothly that passengers could not feel gear changes without watching the tachometer. The air conditioning system was engineered to cool the entire cabin from ambient desert heat to comfortable temperature in under 4 minutes. Matt Farah bought a 1996 LS400 for $1,500 at 897,000 miles. Drove it past 1 million miles with 100 different drivers. Never stranded one. Toyota lost money on every early unit because they refused to cut a single corner. And now you understand the rule. The Japanese called it monozukuri, building with soul. Not profit targets, not planned obsolescence, soul. Every car on this list, the forgotten Corolla, the boring Civic, the cold weather Legacy, the angry Altima, the wrench-only Land Cruiser, the million-mile Accord, the legendary 4Runner, the truck-engined Skyline, the unkillable Hilux, every single one was built under that rule. And the exact moment manufacturers decided monozukuri was too expensive to justify to shareholders is the exact moment your modern car started needing a software update every single month.